Okay, so we're going to go through the review here. We've got, you were supposed to define precipitate. So that's a solid that you're going to produce during a chemical reaction. Okay, this forms with a double replacement reaction. Remember, this is one of the things that a double replacement reaction can cause to happen. So when you have a double replacement reaction, you've got a cation, you have an anion that it's with, then you've got another cation, which I'm going to do in kind of a scriggly font here, and you've got another anion, okay? And when we go through the double replacement reaction, I always tell you to write your cations in the same spot, okay? So I'm going to do my squiggly cation here. And then we're going to reverse the location of the anions. So this anion is going to go with this cation, and this anion is going to go with this cation, okay? And then remember, you have to reevaluate your charges. So if this was a +1 here and this was a -2, I would have had to have 2 of these to balance that out. If this was a +2 and this was a -3, then I would have needed to balance my charges out here. I would have needed a 3 here and a 2 here. When I come over to this side, okay, now these partners have swapped. So this is a -3. I would need 3 of these. And then over here, this anion was a -2. So that charge balances. So I don't need any more. I don't need to do anything with subscripts for that to get it to balance. And then I go through and I balance I've balanced all my charges using subscripts. I'm done with subscripts now. Okay, once those charges are balanced, I can't use subscripts anymore. Now I'm going to have to use coefficients. So I have, for this straight line C, I have 2 here and 3 here. So I'm going to look for the least common multiple, which is 6. So for this one, I want 6 Ca over here, and I want 6 over here. So those are all balanced. My A's then, my straight A's here, I have 3 here. I need 3 on this side. So now I've taken care of that. Now my squiggly C, I have 3 of those, which is good because I've got 3 over here. My squiggly A, I have 2. And over here I've got 2. And so everything's balanced at this point. Does that make sense? How we do that? You balance the charges using subscripts. You balance the atoms using coefficients. And you cannot sneak coefficients in between these compounds. I know some of y'all are doing that. You can't do that, okay? Be careful. All right, activity series. That is a list. We're going to use that to predict if a chemical reaction will occur. This was the roster. So when this is all listed for your metals on the back of your orange sheet for single replacement reactions. Remember, we had, if the thing is at the top, then it'll replace something down here. But if you're at the bottom, and then, you know, if your bottom thing is trying to replace something up here, it's not going to happen. So your metals are all listed on that sheet. Your non-metals, your halogens, are listed on your periodic table. In a chemical reaction, the mass of the reactants will equal the mass of the products. Okay, that's conservation of mass law. We keep going back to that over and over again. That's why we have to balance our equations with the coefficients, because otherwise the masses wouldn't balance out. Okay. Examples that confirm that a chemical reaction has occurred: if you produce a gas, so this is like your CO2 gas, oxygen is a gas, hydrogen is a gas. So any of those things produced will give you a chemical reaction. Solid, that is your precipitate. We would put that at an S. On your solubility chart, it's indicated with an N or an SS in that box. water, which is a liquid, and then liquid, of course. Your diatomic molecules, I get you guys on these all the time. Be careful. If these things are listed by themselves, they have to be there. They have to have a 2 on them. Okay. So for example, if we're making water, okay, I'm going to make some water here. I can't put down this hydrogen and this oxygen without these 2's here. I have to have them there. Okay. Then we go and we balance. So I've got 1 oxygen here. Here I've got 2. So I'm going to put a 2 here. That takes my hydrogen out of whack. So I got to put a 2 there to get that to balance. That makes sense? Okay. So what can be adjusted to balance a chemical equation? This is a chemical equation. We use coefficients for that. Now, I could have another one here that says what can be adjusted to balance charge in a formula. What do we use to balance charge in a formula? Subscripts. Very good. Okay. So if I wanted to write another question here, what can be adjusted to balance charge in a formula? My answer would be subscripts. Okay. When you are doing these problems, write down your compounds first, balance the charge using subscripts, and then once you've done that for all of the items, then go back and balance the equation with your coefficients. Okay, this is solid, this is gas, this is liquid, this is aqueous. Aqueous means that it's mixed with water. So like salt water, for example. Okay, when I put salt in there, when I put salt, like from a salt shaker in there, okay, that salt flows down in here. When it's up here, before I've put it into this water, it's NaCl. Once I get it into this water, it breaks up into its different ions in that water. And we'll talk about why and how that happens in future chapters. But down here, it's going to break it up. And so that condition here is called aqueous. So if this is my salt shaker here, okay, that I'm shaking out my salt, okay, that salt's coming down. When it's in the solid form, it's NaCl. When it comes into the water, the water has 2 ends to it, and one end ends up having a positive charge and a negative charge, and that's what pulls this apart. That condition, when those things pull apart like that, is called aqueous. All right? Okay, so down here, we had to identify these. This is using that flow chart. I gave you guys those flow charts to use. This is a metal oxide and water. A metal oxide and water is a synthesis reaction. It forms a metal hydroxide. So when we write this out, I have to look at my charges here, okay? So when I look at my charges on this, I see that lithium is a +1, and this is a -2. So to balance that charge out, I needed 2 lithiums, 2 plus charges to balance that out. This is just water. Don't worry about charges on water. Water doesn't have charges. Water is a covalent compound. Ionic compounds have charges, covalent don't. Okay? Covalent, they tell you in the name what this is. So water, technically, we call it water, that its common name, but it's actually, dihydrogen monoxide is the technical name for water. The di here tells us that we have a 2 on this. This is monoxide. That means that we only have 1 of those. So we use the name to be able to get, we use the name to be able to get the formula for these covalent compounds. Alex, you awake? All right, when I come over here, I look at my charge. This is a +1 and a -1, so that is balanced. Once I have my charges all balanced out, then I go and I look at my items here. So here originally, before I had that 2 there, I had 2 lithiums over here, and before I wrote the 2 in here, I had 1 lithium over here. So I put a 2 here to get that to balance out. That then gave me 2 oxygens, which balanced my oxygens out, and it gave me my 2 hydrogens, which also balanced that out. Okay? Questions on this one, on letter A? All right. This is aluminum acetate. So aluminum is a +3. Acetate is a -1. So I needed 3 acetate ions to balance out this charge on aluminum. In order for me to have 3 acetate ions, I need to put that polyatomic in parentheses. And then I drop a little 3 down here. Okay, so now I've got that formula balanced. I'm going to move on to my next one. This is potassium hydroxide. Hydroxide is a -1. This is a +1. So that is already balanced. That formula is already balanced before I do anything. I don't have to do a darn thing to that guy. Over here, this is a +3 and a -1. So I have this balanced by putting a 3 down here, but I have to, and this is where people mess up on this one all the time. I have to make that apply to the entire polyatomic. So I have to put it in parentheses. When I need more than 1 polyatomic ion, it has to go in parentheses to make that work. Then my potassium goes here, that's a +1, and my acetate is a -1. So that's already balanced for the formula. I can move on to balancing my equation. Okay, so when I do this, when I'm balancing this equation, we're going to pretend that I don't have these coefficients here yet. Okay, so we're going to get rid of those and just pretend that we don't even have them. When I do this, if my polyatomic ion is the same on both sides, I can keep it together. Potassium, and then my hydroxide is the same, so I can keep that together. When I come over here, I list these in the same order. I don't care what they appear in over here. I'm going to keep them in the same order. 1, 3, because this is in parentheses. 1 and 1, aluminum 1. I've got 3 hydroxide. I have 1 potassium and 1 acetate. So I need to get my acetates up to 3 on this side. So by putting a 3 here, that's going to take care of that. So that gives me 3 potassiums, and it's going to give me 3 acetates. But then over here, I need to get my potassiums to get in line. So if I put a 3 here, that takes care of my potassium, and it also takes care of my hydroxide. And that gets my equation balanced. Good? All right. Moving on to the next one, I have copper 2 nitrate and calcium hydroxide. This is a double replacement reaction. So I have my copper that they told me here. See where this says 2 here? That tells me the charge of my copper. Copper has 2 different options, copper 1 and copper 2, and they tell us in the name which one this is going to be for this guy. Nitrate is a -1, so I need 2 nitrates, and I put that in parentheses. I need 2 of those to balance out this charge. Calcium is a +2, hydroxide is a -1. So I need 2 hydroxides to balance this side out. over here, this is a +2 and a -1. So I needed 2 to get this to balance. This is a +2 and a -1. So I needed 2 of these. And then if we start looking to balance this, I've got 1 copper on each side. I've got 1 calcium on each side. I have 2 nitrates on each side, and I have 2 hydroxides. So that's already balanced. I didn't need to do anything. Make sense? All right, moving on. The next one is a single replacement reaction, and this is where we need to be able to look at our roster. Okay, so first of all, how did I identify this as this possibly being a single replacement? I've already kind of shown my hand here, and we know that this is no reaction, but I'm going to explain to you why. Okay, I have a compound here, and I have a single element. Anytime you see that, that is single replacement. So I'm going to identify this as single replacement. I'm going to go to my sheet, and I'm going to try to figure out what's going to happen. Once I identify this as a single replacement, I need to see kind of what team I'm dealing with. So what is trying to sub in here? Is this team metal or is this team non-metal? Non-metal. This is a non-metal. If I look at my periodic table, I see that it's located right here. Remember, this side of the periodic table is our non-metals. This side is our metals. So this guy is clearly trying to play for team non-metal. When we do that, we use the roster on that periodic table for our halogens. It starts with fluorine, chlorine, bromine, I believe. Yep, bromine, and then iodine. So here is my roster for this. I can see here that right now, fluorine is in the game. That is my star player. That is my Aaron Rodgers of this. And I can see that Lippy is trying to sub in and bump Rodgers onto the bench. Is Lippy going to be successful? Is coach ever going to put me in the game? No, I'm never going to go in the game. If Aaron Rodgers is in there, that's never going to happen. That's why it's a no reaction. Okay? All right. So what's going to happen when Aaron Rodgers retires? I'm going to have to memorize a whole new roster, I guess. But I'll still be at the bottom no matter what. All right. Here's another case of this being a single replacement. I have a compound here. Do you see how there's 2 words here? Okay. I have a compound here, and I have a single element. So now we need to look at this. My sodium is here. I'm going to find sodium on the periodic table, or not on the periodic table, I'm sorry, on my roster. So remember the roster that's on the back side of your sheet. Okay, remember that roster, this guy. Okay, when I look on that roster, I see that sodium is higher than the hydrogen. So sodium has shown up to the game. He's on team metal. He is trying to bump hydrogen out. Is sodium a better player than hydrogen? He's higher up on our roster. He's a better player, which means hydrogen's going to have to go sit on the bench. But remember, hydrogen's diatomic, so he'll still have a buddy. And then nitrogen or sodium's going to go in the game. So sodium's going to go in the game. Sodium is a +2. This is a -3. So I need sodium's a +1. Wow, where's my brain? Still on my NyQuil from last night, guys. Sorry. All right, so that's a +1. This is a -3 here. So I'm going to need 3 of these to balance out this charge. Okay, so I'm going to take these coefficients away for a minute, and we're going to talk about balancing this equation. I'm just going to take those conveniently away so you can't see them for right this second. All right. This one I balanced the charge. This was a +1 and a -3, so I needed 3 hydrogens here. Everybody cool with the way this looks so far before I start balancing the equation? All right. I've used my subscripts to balance my formulas. Once I have those formulas balanced, now I'm going to go back and I'm going to balance my atoms. I use coefficients to do that. So I do my inventory. My PO4 is the same here as it is here. Tell me what you think about it. I did it on both sides. Cool. Thank you. Good. And then the PO4 is here. So NaH, PO4. Okay. I'm going to do my inventories now. My Na, I have 1. My hydrogen, I have 3. There's no parentheses here, so I only have 1 of those. Over here, I've got 3. I have 1, and I have 2. So I've got to get this to balance. I'm going to start with, I'm not going to start with my sodiums because that means that I would end up with a single thing here. So I don't want to start with single ones. I want to start with compounds. I can see that my hydrogen is in a compound on this side, and I need to get it to balance. Now, I can't make this like 3. I can't make this 2. So what I do at that point is I look for the least common multiple. Okay, the least common multiple between 2 and 3 is 6. Thank you. So 6 is my answer here. So I want to get this hydrogen in this compound up to 6. So if I want to get that to 6, what do I have to multiply 3 by to get that to 6? 2. Very good. Okay. So I've got my 2 there. That also affects my phosphate. How many phosphates do I have now? How many phosphates do I have? 2. There you go. All right. So now I need to come over here. I need to get my phosphates up to 2. So what am I going to put here to get my phosphates up to 2? 2. I need a 2 here. Good. So I'm going to put a 2 there. That not only affects my phosphates, it affects my sodium. What does that take my sodium up to? 6. So I'm up to 6 there. Now I'm going to get my hydrogens to line up here. So my hydrogens, I need 6 hydrogens over here. What do I need to put here for my coefficient? 3. Okay. And that will take me up to 6. And I'm almost there. I just need to get my sodiums over here, which is an easy fix. I can get that up to 6 by changing that and putting a 6 there. Okay. Does that make sense how we get that to balance? All right. The next one is nickel hydroxide. This, do you see a plus sign anywhere here? No. If there is no plus sign, that means that we are dealing with a decomposition reaction. If this isn't an element here, that it's one of those special cases, either C, which is chlorates, D, which is carbonates, or E, which is hydroxides. So this is a hydroxide here. So we are going to look and we are going to see what E says on our reaction type sheet. Oops, I thought I had an eraser there. E says on our reaction type sheet for hydroxides. Okay. When I pull that up, it says that I am going to have nickel hydroxide. This is a +2. I know it's a +2 because they told me right here. They told me the oxidation number in the formula. I don't have to guess it. I don't have to look at my periodic table. Nothing. I know it's a +2. This is a -1. So if that's the case, I have to put this in parentheses and I need to get a 2 down here because I need to balance that charge. Now, they didn't tell me what it forms, so I'm going to go to my sheet. It tells me that when I have a metal hydroxide, that it forms a metal oxide plus water. Okay, so I need to find my metal here. My metal was nickel, so it's going to form nickel oxide. So nickel is a +2. We know that because they told us right here. Oxygen's a -2. So when I write that formula out, that formula is already balanced for charge. Okay, and then I just need to write water down, which hopefully you guys know the formula for that. Then I need to go back and I need to make sure that my equation is balanced. Well, I have one nickel here and one here. I have 2 oxygens because we're going to distribute that 2 through the parentheses. I have 1 here plus 1 gives me 2. And then I have 2 hydrogens here. Good. All right. Next one, calcium and zinc nitrate. So I have a single element and I have a compound. So this has to be single replacement. If this is single replacement, I need to look at my single element and see what team it's playing for. It's playing for team metal, right? Okay. It's on the left side of my periodic table. When I'm looking at team metal, I go to my activity series on my reaction type sheet, and I see that calcium is listed above zinc, which means that calcium is going to sub in for zinc. So zinc's going to go and sit on the bench by itself, and calcium's going to go into this compound. So how do I write that out? My calcium I write down, it's not a Brinkelhoff, it doesn't get a subscript. My zinc is a +2. My nitrate is a -1. So that means that I'm going to need 2 nitrates. This is all of this is nitrate. Zinc nitrate, I need 2 of those for every one of these to balance the charge out. Calcium, I need a +2. This is a -1. So again, I'm going to need 2 of these to balance this charge out. I have to put it in parentheses because it has to apply to the entire polyatomic ion. Then I put my 2 down here, and then this is my zinc by itself. Then I just make sure that the equation is balanced using my coefficients. Okay, this is already balanced, so I didn't need to use any coefficients because it's already done. And sometimes they are. Sometimes they balance naturally and you don't have to do any coefficients at all. The next one is magnesium chlorate. Magnesium chlorate, this is one thing. There are no plus signs here anywhere. So if this is just one thing, it has to be decomposition. There's nothing here. It's just one item. There's nothing here to synthesize or add in. There's nothing here to replace it. So it has to be decomposition. So my magnesium is going to go here. And I've got to figure out what this is going to do. So this is special case C from your decomposition sheet. It says that it forms a metal chloride and oxygen. So then I need to make sure that my charges are balanced on my formulas. This is a +2. This is a -1. This is a +2. This is a -1. So here I need more than one chlorate to get this to balance. I need 2 of them. So I'm going to put it in parentheses and put the 2 out here. Here I have a +2 and a -1. So I need 2 chlorines to get that to balance out. And then I'm going to go and I'm going to balance my equation using coefficients. I cannot use, I can't keep this polyatomic ion together. I have to break it up because it doesn't appear the same on both sides. So when I look at these, I've got magnesium, I have one of these. My chlorines, I have 2 because I've got to distribute that 2 through the parentheses. And then the oxygens, I have 6. Over here, I have Mg. I have 1 of those. I have 2 chlorines, but my oxygens are off. My oxygens right now are at 2. And I need it to be at 6. So if I multiply that 2 times 3, then I'm up to 6. And I have my equation balanced. Okay, questions on that? All right, the next one is a combustion reaction. Okay, and I gave you rules for combustion reactions. Do you remember the rules for combustion reactions? I told you that if this is an even number here, that we're going to put a 2 out front. If it's an odd number, we don't do anything. We just start balancing our carbons. So I'm going to balance my carbons. On this side, I have 5. On this side, I need 5. So I put a 5 here. Then I balance my hydrogens. I have 12 here. I need 12 here. So what times 2 would give me 12? 6. Then I add up my oxygens on this side. I have 10 here. 5 times 2 is 10. I have 6 oxygens here for a total of 16. So I need 16 oxygens over here. I need to put an 8 here to get that to balance. Make sense? Good? All right. So the next one here, we can identify as a single replacement reaction because we have a single element and we have a compound. Be careful with magnesium. People get that confused with manganese a lot, and it's not, it's magnesium. Okay, so magnesium here, silver is in with sulfur. So this is a +1, this is a -2. So I needed 2 of these to balance that charge out. I need to identify what team is trying to sub in. Magnesium is a metal. So I need to look at my activity series on my sheet here. Okay. And I'm going to see that magnesium is higher up than silver. Silver is way at the bottom. So that means that magnesium is a better player. It's more reactive than the silver. So magnesium is going to go into the game, and silver is going to have to go, and it's going to have to sit on the bench by itself. Okay. So silver is going to go in. I've got a +1 here and a -2 here. So I need 2 of these to balance the charge out. Over here, I have a +2 and a -2. So that charge is already balanced. I don't need any subscripts. I have my charges all balanced now with my subscripts. I'm going to go back and look at my atoms for coefficients. I had 2 silver over here, so I needed 2 here. So I put a subscript 2 there. My magnesiums are balanced and my sulfurs are balanced, so that guy is done. The next one is a double replacement reaction. I have my potassium here and my sodium here. This is a +1. Oops, why is this not writing? There we go. This is a +1, -1. This is a +1, -2. So here, remember when we do these, I told you guys to write in your cations in the same spot. and then swap partners. So the chlorine is going to go over here with the potassium, and the carbonate is going to go with the sodium. Okay, so when I do this, I end up with I have to balance my charges. Okay, potassium's a +1. This is a -2, so I needed 2 of these to balance that out. My sodium is a +1. This is a -2, so I needed 2 of these to balance that charge out. Once I have the charges balanced, then I go back and check my atoms. And this guy, the atoms should have had a 2 here and a 2 here to balance. But notice that this says no reaction. We need to talk about why. Okay. If you look these up on your chart, you're going to see an S in your chart for this one, meaning that it's soluble, and an S in the chart for this one, meaning it's soluble. So nothing's changed. Remember when we started out the reaction here, all of these things were aqueous. We had sodium ions floating around, we had chlorine ions floating around, we had potassium ions floating around, and we had our carbonate ions floating around. When we went through and we mixed all of this together, that was still the case. So because nothing had changed on this side, everything was the same, nothing had hooked up, so to speak, and become a compound. Nothing changed. We had a no reaction there. All right, this one's always a fun one. People want to know how to do this one. Okay, so this is looking at essentially creating your own activity series. Okay, so here we had a star, and no, I'm sorry, this isn't the activity series. This is just showing you elements. I think the activity series is a little further. Yeah, that's what that one is. That's down further. So this one would be synthesis. We would bring these together and make a synthesis reaction. On our example in class, we had a cat, we had a fish, and then the cat ate the fish, if you remember right. Decomposition, we had an egg, and then we had the egg shell and the chick off to the side. Single replacement, we had a bone, and we had a dog with, no, we had a dog with a bone, and we had a steak here. And then the dog picked up the steak, and then the bone was left off to the side. And then here we had a bunny with a bone and a dog with a carrot. And then the bunny ended up with the carrot, and the dog ended up with the bone. Okay, so using symbols. These are asking what these decompose by. All you have to do is look on your sheet. You'll have that sheet for your test, so you don't have to have this memorized. This is letter Roman numeral 2, decomposition D. This is Roman numeral 2, letter E. And this was Roman numeral 2, letter C from your sheet. This is at the bottom of your solubility chart. Remember, when you go through decomposition of these two guys, they're very special. Anytime you get carbonic acid, it's going to form carbon dioxide and water. Anytime you get sulfurous acid, it decomposes to H2S, which is a gas, and water. This ends up being from the side over on your reaction type sheet from this little call out box. Okay. If you have a very active metal, this is Roman numeral 4E. They're going to form metal hydroxide and hydrogen gas. This is Roman numeral 4F. And it forms a metal oxide. This is an oxide. This is a hydroxide. So this is oxygen and some sort of metal. This is hydroxide and some sort of metal. Then the less active was Roman numeral 4G. And that's no reaction, like with copper or lead or silver or gold, all of those things. All right, so down here, let's not cheat and look at the answer, okay? Let's build this together. We want to look at this example here and try to figure out how this works. So we have symbols here, okay? This % sign and this is your number sign. The number sign is going to go and sit on the bench, and percent sign is going to go in the game. That means that percent sign is more active or higher on the roster than number sign. Down here, dollar is trying to go in for number sign, and it doesn't work. Which one is more reactive? Which one should be on the bottom of the list here? Should it be dollar sign or number sign? Dollar sign, because it's less active. It didn't work. That's the lippy. Okay. At sign bumped percent sign out. So that means that at sign is more reactive than percent sign. Does that make sense how you can build your own activity series? All right, we're running out of time. So I'm just going to show you these last few. Now these are called those net ionic reactions. You're not going, for your test, you're not going to have to do this bottom part. So you just need to make sure that you can do the top line here. So check your answers on these. Okay. And then I will have this video uploaded for you so you can watch the video again tonight and reference that if you need to. You can pause these last couple slides and check your answers. When you come back to me on, what do I see, Friday, we have Aspire testing. So if you're a junior or a senior, bring something to work on. Freshmen, sophomores, you're taking your Aspire test.